Good afternoon, everyone. I'm Dave MacKeracher, and I am a partner with the Mitchell Partnership. I'm one of the few people who actually stuck a picture up there on that opening slide. That's actually a picture of a mechanical room at Pearson Airport. I don't have the fabrication drawings, but Sayers and Associates, who was the mechanical contractor for this project, actually had their fabrication drawings done in a BIM software program and had it all fabricated. The shop drawings were all generated that way and were actually pretty slick, and you can see the end result was pretty good. Anyway, that's all went into storage, and I had a hard time finding the drawings before this presentation. So anyway, carry on. There I am, pretty handsome fella. Anyway, that just talks pretty much the same thing that Ian was just talking about. Graduated in 1987, came out of Ryerson Polytechnical Institute and got hired by Ribke Smith and Ginsler, by that man right there. Peter Elton interviewed me and hired me. If it weren't for Peter, I would probably be a millionaire on a beach in the Bahamas right now. Anyway, so I took on a role at Ribke as a junior designer, and I have worked my way up to become a partner at the Mitchell Partnership. All the rest of it's pretty impressive stuff. If you got any questions about that, just give me a call. Here are some of the projects that I've been working on. Actually, the most important picture is that picture there on the end. That is a picture of me kissing the Blarney Stone, so you'll know everything that comes after this as a result of that. Casino-Rama expansion, the Museum for Human Rights, which is going to feature big in this presentation, Casino Brantford, and Pearson Airport. Pearson Airport's particularly important because I was the field engineer there and spent 6 years watching that thing come out of the ground into the facility that it is today. Some other projects, Durham Regional Courthouse, Quinte Courthouse, which is under construction right now, the Royal Ottawa Hospital, not far from here. These are 3 P3 projects we worked on, and the William Osler Hospital. The TIFF Bell Lightbox, which is downtown Toronto and home to the International Film Festival we did the commissioning for. That picture up there in the corner is a picture of me and my wife. It was on the front page of the Detroit Free Press the day after the casino opened, and it was a real annoyance to the project architects that their engineer made the front page and not them. So I include that just as my little dig. The Mitchell Partnership, well, we've done some pretty big stuff. TELUS buildings in downtown Toronto, the Royal Ontario Museum, RBC Centre in Toronto, and the Air Canada Centre in Toronto. The rest is all pretty impressive words, which I'm sure you're all reading with great interest right now. So getting into the meat of the whole conversation, back in 2008, Autodesk found out that we, the Mitchell Partnership, had been contracted to design the Canadian Museum for Human Rights out in Winnipeg in Revit. And we were using, and we have used, Revit MEP 2009 since then. And Autodesk asked me to tag along on their tour 3 years ago to explain to everyone how we were implementing BIM and Revit MEP. And I was really impressed and thought, wow, this is great. And at the time, took these screenshots of some of the stuff that we had produced at the time, and I was in fact really impressed that we had managed to get this far in such a short amount of time. And little did I realize at the time just what a frustrating path we were going down, which we've grown from that and learned from that, and I'm going to basically walk you through some of these issues that we came across. So Revit MEP at the time, I think, was in version 2, and we were basically trying to muddle through some new software issues and trying to make it all work. At the time, there weren't an awful lot of families available, so we were taking anything we could get and throwing it into the model. For instance, these air handling units that you see down here in those fan rooms are either just blocks, squares that we connected the ductwork to, or they were 3D AutoCAD 3D AutoCAD files that we would drop into the Revit MEP software. I mean, there is no intelligence to that. They're just there as placeholders for us to connect to. The other thing that we had issues with, and I'm sure some of you other guys mechanically may have had issues with, is we can't connect the plumbing fixtures, and we still can't connect up the plumbing fixtures. We have to leave a 1 millimeter gap between the water connections and the drain connections. Otherwise, the model continually wants to recalculate the fixture unit, and it just grinds everything to a halt. So one of these things that we've done to get around that is just to leave that 1 millimeter gap between the piping connections and the fixtures. You don't see it in the graphical representations, but if we ever did run those analysis programs, we have all kinds of open-ended connections in the model. Some of the other things that we got out of that those early presentations were just some very simple representations. One of the things you'll notice is the building itself is very complicated has a very complicated geometry to it. There's all kinds of kinks and elbows in this thing, and there really is no vertical wall in the place other than the walls in the elevator shafts. And even then, some of them aren't all that straight either. One of the things we did use the model for became very important for us, other than the graphical representation for the HVAC and the mechanical services, was we had to go back to the city of Winnipeg to explain how this thing was going to work. They didn't understand the exiting. They didn't understand the fire protection. And one of the things we had to take with them is we took these model screenshots to the city of Winnipeg and even the Navisworks model, and we had to explain to them how the sprinkler protection was going to work in this giant void space that you see in the middle here. Essentially, if you're going to follow the rules of the sprinkler coverage, the floor plates, individual floor plates have to have their own zone. So we would have had to have had something like 10 different zones at the top of this roof structure, covering each of the different floor plates that would be exposed to. So we took the city of Winnipeg through this and explained to them that really we wanted one zone or two zones in that whole big open concept, in that whole big open space that would just basically cover the entire open gallery. And I'll take you through a couple of these other slides. This is what they call the Tower of Hope, and it's just basically crisscrossed with all these different ramps that interconnect between the different gallery spaces. And again, we just explained to them that we were going to deal with this as one sprinkler zone, and the obstructions that were presented by these gallery ramps, we would just deal with them as obstruction coverage rather than as individual zones. This is bird's eye view shot looking down on that larger bowl structure, and you can see all the different floor exposures as a result of that, and just how difficult that would have been to accommodate in the sprinkler coverage. So again, look at this BIM model as not just a tool that you can just show all your stuff graphically. I mean, it becomes a very useful tool to try and explain to people who have to issue things like building permits. And eventually, he caught on and he understood what we were trying to do and the complexities of the building, and we got the permit. Here's a couple more shots of the inside of that bowl, trying to explain how the complexity of the geometry. And from those simple images, this is what we've come up with. I mean, here's the chiller room complete now, and now we're getting the elements that the families from the chiller manufacturers and from the heat exchanger manufacturers, so that we can actually, we haven't imported the data into it, but it would be relatively simple for us to do it. This is an interesting shot here at the bottom corner. We actually rolled the model up so you can see the underground drainage looking from below. You also see the caissons are extending down from that, so you're actually looking at the underside of the building from that perspective. A couple of other things just of interest. There's this compound, our service compound is at the top of the picture there with the cooling towers and the fluid coolers and all the piping along with it. And this corner shot here at the bottom, those are 6 smoke exhaust fans, which we explained also to the city of Winnipeg, because the high-rise building requirements are that we provide 6 air changes of smoke exhaust for that space, and how we got around that was can't remember what it is. I think it's almost close to 4 million CFM we have to exhaust out of it. It's phenomenal, just because of the volume of the space. And you don't really appreciate the scale of that, but those are, I think, the second biggest fans that Twin City make in their catalog. Now, here's an interesting group of slides, and I'm just going to start this off with, when do you know that your BIM is coordinated? And this next series of shots is pretty interesting because, you know, here it is with the electrical, the mechanical, and the architecture. And you can start turning things off and you see, okay, everything's still there, and take the ceiling off and all of our sheet metal's in there and our sprinkler heads are in there and everything's working out fine. Sounds good so far, right? Let's go on to the next slide. This is a screenshot of the consultant's model with our ductwork snaking through some of the steel. This is the Yawley steel model that's in the design model, and so far everything works okay. We add to that, we take out of that the Yawley's model and we drop into that the Walters model. This is the Walters steel fabrication model. You can see the difference between the Yawley's model and the Walters model, and you see all the differences with the steel connections. And again, so far, everything looks pretty good. No problems, no coordination issues. To advance that a little bit more, this is one of the more complicated pieces of the museum. You can't tell from this shot, but there are about 3 different surfaces, none of them vertical in here, and you can see this in the next shot. Oops, sorry. When we take away the drywall, you start to begin to see some of the complexities of the steel that was required in order to build this and to support the structure. This connection on the right is one of the most complicated things I've ever seen been built. Now this again is the Yawley's model, and this is the Walters model. So you start to see some of the issues that we didn't see in the design model that actually show up on site. And it became a problem, and I'll get to those in a second. And just for reference, that's actually what it looked like in the field. It's actually almost identical to, well, it is identical to the Walters model. So here's where it gets interesting. Here's a fully coordinated design model with the Yawley's model. And here's what happened when we added the Walters steel into it. And you see that light fixture's been cut in half. Again, it was a clean model when we turned it over to the constructor, and it came back with the clash. This is another issue we came up with. So again, a clean model that we delivered to the constructor, and it came back with our pipe embedded in all kinds of steel. Now, we got a 500-page clash detection report from the constructor after this, and we were told that it was on the consultants to resolve. And we took great issue with that, and we still are taking great issue with that. It hasn't really been fully resolved yet, but I really want to take this opportunity to show you guys in the audience. When we talk about BIM and we talk about coordination and we talk about clash detection, it's all fine and dandy through the design stage. But it really comes home to roost when you start getting into fabrication and who owns the resolution of these kinds of issues. So just, beware, BIM is not the silver bullet that everybody is trying to make it out to be. There are some real issues. It's a great tool, don't get me wrong, and it has some great potential, but, these pictures prove out my point. So really, what I want you guys to understand is the model is really only ever as good as what you put into it. Now, there were a whole bunch of other issues that you need to consider, like knee bracing, shelf angles. In fact, the shelf angles became a real issue as well. In the exit stairs, the shelf angles, we had a clash with the fire standpipe. So to resolve the clash, we pulled the fire standpipe away from the shelf angle. And as a result of that, we encroached on the exiting distance. So we ended up having to push it back again and have the steel fabricator cut the shelf angle. So there was, when you start looking at the time required to resolve some of these and the level of effort required, it didn't, none of that showed up in the design document. This is all post-design, and we're into construction. So, you know, buyer beware. Here's a couple of other projects, just sort of, now that I've got you scared of it. There's a lot of other stuff that's really good about it, too. We're getting really good at working in Revit MEP, and we know that the Human Rights Museum was, you know, it's a one-off, and you'll never do another one like that again. Or maybe we will, who knows. But we now know where those pitfalls are and what they are and what to ask for. But getting into some of the simpler buildings we've done, here is the downtown Lexus building in Toronto, which we worked on as well. You can see that there's a screenshot we took of the Revit MEP model, and I think that's a screenshot of the Navisworks model as well. Here's a couple of screenshots again. You see the drywall cladding around the edge of the ceiling, and then we turned it off, and just to show all the sheet metal connections to the diffusers in the space. Ripley's Aquarium in Toronto. Again, this is one of these projects that we worked on, and we took it upon ourselves to do the mechanical rooms in Revit, just so that we could turn the model over to the contractor with some sense that what we had designed was going to fit. These are usually issues that we have with contractors when we turn over 2D models, is they'll turn around and say, well, it's great, everything looks great, Dave, but you know, we can't build it, it won't fit. But you know, now with Revit, we can at least give them a design that we know worked in one instance, and if they want to come up with alternatives, they're free to, you know, provided they still work. But you know, as a basis of design or construction going forward, they at least got a model that we knew worked. Here's a couple of other shots of the mechanic rooms in there, the boiler plant down here, some fan rooms up there, the chiller plant. And I believe that other one is another, well, I guess that's another shot of the back of the boiler plant. And just another view of the chiller room, some of the piping, some of the complexities. Here's another project that we, again, took it upon ourselves to produce a Revit model for, and we were not contracted to. But this was a P3 project, the Quinte Courthouse in Belleville. Through the pursuit phase, we actually laid out the mechanic rooms in Revit, just so that we knew that the pricing that was being put in by Modern Niagara and their sheet metal contractor included for all the fittings and all the piping and all the offsets that needed to go into this to make it work. So what you're seeing here is a reflection of, well, that's actually a shot of the current model. At the time, it was a much more simpler model, but still everything worked. And what you see down in the corner there is the sheet file that's been generated out of that model as well. There's a couple more views of some of the mechanical rooms. And you'll notice in that this blue beam that's passing through here, we actually went through and modeled the structural steel in there just to make sure the sheet metal fit underneath it. We were working without a model from the structural engineer this time. Everything you see in that was drawn by TMP. Again, this is shots of the penthouse mechanical room, the air handling equipment. There's some of the boiler plant up there. Actually, this is the domestic hot water plant. The chiller plant and the engine generators, or the diesel generators here. And a couple of other interesting things. The building operator, Morgard, we took them through the models. We walked them through the models to show them how all the equipment was to be serviced. This is, we actually found this motor as part of that walkthrough with Morgard was inaccessible, so we ended up having to rotate it within the model. It's just another good tool, and Morgard sort of challenged them. It's the only thing they could find to really criticize us about, but it was a pretty easy fix. The other issue, the other thing down there, that's actually a little study we had to do for the architect to show them how the cleanouts for some of the building drainage were going to work above an exit, because we had to separate those cleanouts from the exit. The city of Belleville would not let it be accessed through the exit, so we showed them that they needed to construct a separation around it in a platform and an access door. It's kind of silly because you still need to put a ladder in front of the exit door to access it, but it worked, and the city of Belleville bought it, so there you go. This is another drawing we did of the courtrooms, again, this was more for the benefit of the sheet metal contractor. One of the things we learned about courtrooms, they have an incredibly difficult requirement for sound levels to meet. We get a lot of regenerated noise inside ductwork once you start putting balancing dampers on it. So we have to design the sheet metal so that the air is self-balancing, so there's equal pressure drops to each one of those diffusers in there. And you don't see, from the 2D plan, you don't get a very good feel for how many fittings in the sheet metal are actually required in order to get that equal pressure drop. And so we showed this to the sheet metal contractor, and he assured us he had all of it included in his bid, and of course he didn't. And we spent a lot of time arguing about this afterwards. But still, it was a great design tool, and for us to demonstrate, first of all, the sheet metal fit inside the ceiling space that we were given, and that we could accommodate the self-balancing requirements. This is another project we did in Winnipeg. An expansion to the Club Regent Casino. They're adding an entertainment center, and the acoustical consultant came back to us with some pretty strict requirements about velocities in the ductwork, and this was the plan drawing that we ended up producing out of a Revit model. You'll see we ended up having to snake this thing through the trusses, and to the point where, you know, we just missed, we worked around the trusses and worked around the flanges of the trusses so that all of the sheet metal fit. It was a very time-consuming exercise for us, but one that was really worthwhile because, again, we turned this over to the sheet metal contractor, and they were very happy that we'd done this for them. So this is under construction now, and you know, hopefully it works out in the long run. There's some other coordination elements in there, so we introduced the roof drains. They're in there with the sheet metal as well. Here's a view of the entertainment center with the trusses up above and the placement of the diffusers. And here's a shot from the stage looking back at the space. This is an interesting picture. Sorry about the coloring. I mean, we're poor engineers and didn't spend an awful lot of time coloring this. But we did this as a study for a data center that's being put in at the CBC building in downtown Toronto. They've leased it out, and they need to put in some cooling systems. And if you look at the smaller pipe, actually has to offset around this, underneath the beam, come across and down and back around and then through there. And this was a study we had to do to prove to ourselves that what we were going to do could actually fit. Again, this is just something that we did for ourselves. So. And we took this back to the client and explained to him, you know, in order to make your plan work, this is what we have to do. And he was quite happy that we had found a solution for him, but wasn't happy about the cost. So they actually did it a different way. But again, you know, this is the ability to do these studies and to sort of satisfy ourselves that what we're doing is going to fit. Here's another little project we were doing, the Women's College Hospital expansion. We had to help Black & McDonald understand how the supports for the cooling towers were going to work, where the point loads were on the structure below, and how that piping was going to be supported around the tower, and how it was going to be transferred back down to the structure. So we did this study for them, and then they took it, and then they added all their hangars after that. Windsor Tower. This is a new office tower that's being proposed. Actually, Ian told me it's actually not the Windsor Tower anymore. It's the Deloitte Tower, sorry. It's a project that we're working on with Intuitive. Anyway, again, this is another spec office tower that we're now working in Revit. And you'll notice the difference between the Human Rights Museum air handling units and the air handling units we have now. I mean, these are all fully developed families in Revit that we plunk in, and we do all our sheet metal connections to, and all our piping connections to. So you can see the evolution of how we've gone, you know, in the last 3 years from some pretty rudimentary stuff to some stuff that's actually getting pretty elaborate. This is still the Deloitte Tower again, with the sheet metal and the plumbing, the mechanical plant drawings. 16 York Street is another office tower we're working on in downtown Toronto. And again, These are just some screen captures of the mechanical rooms at the penthouse, some of the equipment that we've dropped in. These are all just sort of work in progress, just to let you know that, you know, these are our projects that we've got now. The Bay Adelaide Centre, the East Tower, these are core details that we were developed with the architect to show them the spacing and the requirements and the plumbing requirements for their core washroom spaces. 1 York Street, which is another project that we're working on. And you can start to see, we played around with some of these views, and my modeler started to get a little artistic on me with that one image. It's still pretty impressive. These are just some more images of all the piping arrangements. And getting to our next steps. This is sort of Revit past and Revit future. So essentially what we've done within TMP is we've taken our drafting staff and we've converted them into modelers. And we are now in the process of taking our engineering staff and converting them into modelers as well. So they're becoming more fluent in Revit MEP. So what we're doing, we're starting them off is actually importing or inputting some of that performance data onto some of those families, those pumps and those heat exchangers and those fans, so that eventually we can turn that information over to the owner and he can click on those and he can find out all the information he needs about that equipment. The other thing that we are doing, or we are learning to do, is to redraw the thermal boundaries within the model. The spaces that the mechanical engineers are interested in are not necessarily the same spaces that the architects are interested in. The thermal zones generally for mechanical are below the ceiling. The conditioned spaces are below the ceiling. The first 15 feet of an exterior wall is a thermal zone, and beyond that on an open plan office would be considered an interior zone. Whereas an architect would look at that as just one big space, and the ceiling space above that, the ceiling void above that, would also be considered part of that same space. Thermal zones are looked at very differently by the mechanical engineers. We need to understand the spaces that are conditioned and the heat losses and gains through that building skin. So we have to go back in and we have to redefine those spaces so that we can export that data using a GBMXL software or export software, and we take that and we put that into energy modeling software. We have done this successfully twice on two very small projects, and that was it was very difficult because of let me back that up. We've taken the architectural information out of two small projects, and just to prove to ourselves that we can do it. And it was very time consuming because of the way that the spaces were bounded by the architects. They weren't bounded properly, and that's why what we've learned is the way to do this now is for us to go in and actually redefine those spaces in a separate mechanical model for thermal zones. The other thing which is very much a part of our future working with Revit is the energy modeling software, and we see this as becoming a very, very important tool to us. Probably more so than even the graphical representations, because of the way some of the energy efficiencies of the building we're being contracted to meet. We need to be able to do some comparisons with using an energy modeling software, and we use Train Trace. There is a lot of flexibility using Trace. Right now, the energy modeling software that is the flavor of choice is this EE4, and this is mostly because of LEED and people trying to meet the energy modeling requirements for LEED. Most of the energy modeling people out there, software companies out there, will utilize EE4 because it's basically if the reviewers at the at CAGBC get an EE4 model and it shows compliance, then it's pretty much a rubber stamp. If they see it in any other kind of software, they start to dig through it and question it. So, but there's a lot of limitations in EE4, and what we're starting to see is some of the more innovative designs that we are producing that will reduce the energy consumption in a building are not properly modeled in EE4. So we have to take it into a different type of software, which will recognize a lot more of these different types of innovations that we're utilizing. Train Trace is a very good tool for that, for us to use as a means of comparing one system to another. So there's a lot more, like rather than demonstrating compliance using EE4, Train Trace will allow us to demonstrate compliance with ASHRAE 90.1, which is the second path of compliance in the Model National Energy Code. So we see there being a fundamental shift in that modeling software, utilizing EE4 away from, a shift away from EE4 in the future toward that ASHRAE 90.1 as some of the innovations, we want our innovations to be recognized in the modeling software. So there is going to be a push for us, at least, to utilize something other than EE4. And that sort of brings us to the last point we haven't read there is we are now at a point where we actually think that we can do 90% of our work in Revit efficiently and still make money at it. And the only thing that's really holding us back right now is the fact that the architects are still working in AutoCAD, which is a lot different than what we were being told back in 2008, which was, we need mechanical engineers that can work in Revit, and now a lot of our clients are sort of taking a step back from that approach and saying, well, yeah, we do want Revit, we want to go Revit, but just not yet. So, but we're now at the point where we're quite comfortable, at least working graphically with Revit MEP in all types of buildings and building types and applications. Anyway, and that's where I'll leave it off. So, any questions?
A question I have going back to just your last slide and some of the lessons that you've learned out of over the years about setting zones. And I think it's a good idea because I learned very quickly with consultants in Alberta that my concept of a volume is not the same as theirs. So how did you reconcile that, or maybe how would you, given that architects are working in AutoCAD and there's no such thing there, but let's say you and I were working together, how would you reconcile that when it comes to obviously the effort? And I, for one, don't do work, the next person's work, unless I'm paid for it. So if you're doing the work, how do you see that reconciling itself?
What we do is we actually take your model and we copy it, and then we redefine we define the zones, the thermal zones within your model, and we extract the you have to bear with me because this was explained to me by my modeler how he was doing it. Is he redefined the zones in the model, and he extracted that volume and that bounding geometry out. Now I say we did this successfully on 2 projects. It took him quite a bit of time to do all of this. So it's still not a very simple process, but again, we're at the very sort of bottom end of that learning curve. But it's one that we are forcing ourselves to learn because we see this as a service that we need to provide for our clients. When we go back and we have a mandate to achieve 37% better than MNECB, very quickly we want to know that the building geometry will lend itself to that. And in so doing that, we actually have to go back in and extract that data out properly. In a format, the problems that we had were walls not meeting roof. So the volume was basically infinite the way it was coming back in. So we, as part of our redefinition of those spaces, we closed those gaps. Without touching your model, we closed those gaps. And we redefined the zones so that the ceiling is the boundary, not the roof deck or the floor slab. And that ceiling cavity itself becomes a whole other thermal zone in the energy model. So The actual process of how the finer detail of how we went about doing that, I couldn't tell you how we did it. I mean, I could find out and I could bring Andrew here and he could explain it to you, but he was quite frustrated by the whole process. So like I said, we're still at that bottom end of the wedge. But what I understand is through these there are these sort of Revit online forums that Andrew goes into. Well, actually, all of our guys go into it now and sort of type in questions, and they get back the answers. And I don't know if anybody in here is aware of these online forums. By all means, get in. There's lots of questions and answers that basically are posed and answered by these user groups. And the answer that we got back from this sort of online forum was the way you do this is to rebound those zones on your own, rather than rely on the architectural boundaries.
Good. And my second point, and thank you for that, David. It's very clear. Second point has to again do with the traditional relationship between architect and his consultants.
Yeah.
And traditionally there was that nemesis thing called the coordination fee.
Yes.
How have you dealt with that?
Well,
how have you reconciled out that you're forced into doing coordination, and you're not compensated to do that?
Maybe I should bring you with me to Winnipeg. You can explain this to the clients and to the constructor and the rest of them. It's an argument. I'll be honest with you. We are having a big discussion over extras and additional services. I mean, you saw those conflicts. I mean, those were not ours to resolve, but yet they landed in our lap. And there is, we have put in a claim for an extra for all of that work. I don't know how else to explain it. Really, it goes back to that what I had in that one slide is the model is only as good as what you decide to put into it. I mean, if you're not going to model that steel, the client and the owner and the architect and everybody needs to understand that there is the potential for additional costs to change these things later on once we bring in that other information. Either that or you have it structured. I mean, in a typical design, I mean, this was all done in 2D. The GC, we were just held the GC responsible for it, saying you were supposed to coordinate this with your trades. And the structure of the contract at the Human Rights Museum is a little different. I don't really want to get into it, but basically PCL holds the contracts on behalf of the museum. It became a very delicate situation, and the easiest way out for the architect and for the constructor was to get the sub-consultants to review and resolve those. Now, that doesn't change the fact that we spent a lot of time. 500 pages of clashes is what we got when the Walters model was run with the clash detection report. So we went through all 500 clashes, and we identified what they were, and we identified the resolution to them. So we spent quite a bit of time doing that, and yeah, we have a claim in for that time.
So then, just to close off my discussion on this point of opportunity, would it be unreasonable then, here's something that we've done out west, is it's all about risk management. So shunt, move the risk, not pass the risk off. But what we've done is saying we will not do the final coordination until we receive a fabrication model. What you'll get is simply an understanding of the design, but the final coordination will take place, and therefore there'll be a portion of a fee attributed to some point when that model becomes available. Is that a reasonable thing for you, or would you be cautioning me not to go that path?
Well, turning the model over to the contractor with the understanding that they now own all the resolution and the risk associated with it would probably, in hindsight, would have been a really good idea to have at least flagged and identified that to the ownership. at the museum, so that there was no misunderstanding that really this was now in their court to resolve with their steel fabricator and with their mechanical contractor. That's not what happened, though. For a lot of different reasons, things got left out, either intentionally or not intentionally, out of people's contracts at the front end of it. And I really don't want to get into this whole conversation about how that structure of that contract is set up and how it's being implemented. It's almost complete, and I'll be really happy to see the end of it. Quite frankly, we've learned quite a bit using the Revit software and how we manipulate, our services through the building itself and how it gets coordinated with other elements. But really, for us, the show is not over out there, and it won't be for quite some time. I'm concerned.
Was there a BIM execution plan done, and by who?
No.
Okay.
Back in 2008, when we first started it, we had no idea what we were getting into. But we've learned quite a bit since then, and let me tell you, I have my own little set of issues to be resolved before we take on another Revit project like that.